Hi, let us look into the problems on three-phase induction motor. Okay, consider the first problem. A 10-pole induction motor supplied by a 6-pole alternator which is driven at 1200 rpm. If the rotor runs at a slip of 3%, what is its speed? Okay, so let us note down the given data. They are telling that a 10-pole induction motor is supplied by a 6-pole alternator. So we need to consider the cascade connection of the motor and the alternator. So the alternator actually supplies to the induction motor. So let us take alternator first and then the induction motor. So let us note down the number of poles of alternator as 6 and for the motor as 10, and also they are telling speed of the alternator as 1200, so which we have noted here. So if the motor runs at 3% of slip, then what is its speed they are asking. So we know the relationship between slip and the synchronous speed, that is percentage S is equal to ns minus n by ms. Ns minus ms slip speed divided by ns is the speed of rotating magnetic field. So here let us calculate the synchronous speed of the motor first. Okay, synchronous speed of the motor, which can be calculated as 120f divided by number of poles of the motor. So we don't know the value of frequency, so let us first calculate the frequency by making use of data for the alternator. Okay, so because the supply frequency will be same here, right, it will not change. Therefore f is equal to 1200 which is a synchronous speed of the alternator into a number of poles as 6 divided by 120. So that gives us 60 Hz. So now we will substitute the 60 Hz in this ns for the induction motor, and number of poles for the motor is 10. So we will get synchronous speed of the induction motor as 720 rpm. And now we have got the value of ns and also the slip value. We can find the speed of the rotor, which is 698 revolution per minute. So slip they have given as 3%, so let us take that value of 3. Okay, so a 4-pole 3-phase 50 Hz induction motor runs at a speed of 1470 rpm. What they are saying is a 4-pole 3-phase 50 Hz induction motor. If it runs at 1470 rpm, find synchronous speed, slip and frequency of the induced EMF in the rotor under this condition. Okay, so we need to find the slip, that is using this equation, percentage S is equal to ns. Sorry, there should be minus n divided by, which we have written properly while substituting, okay, divided by ns. Okay, so in order to calculate, we'll find the ns first using 120f by p equation, and we have known the value of f and the p here, 1500 rpm. So the slip can be calculated using 1500 as ns, and they have given the speed of motor as 1470 rpm, which we have substituted here, and the percentage speed is 2%. So we know the relationship between the frequency of the rotor and slip and the supply frequency as fr or f dash is equal to s times f. So here F dash is this frequency of the rotor, which can be calculated as the slip times the supply frequency. The value of slip is 2%. So let us take it as 0.02 and multiply that with the supply frequency, which is 50, will gives us 1 Hertz as the frequency of rotor. Okay. Another problem, an 8-pole alternator runs at 750 rpm, and if it supplies the power at a 4-pole induction motor, the frequency of rotor is 1.5 Hertz. What is speed of the motor? What is a slip? Okay, so here we need to find speed of the motor and also the slip value. Okay, so what they are telling is again there is a cascaded structure here. The alternator actually drives the induction motor, and they have given number of poles for the alternator as 8 and speed of the alternator as 750 rpm. Number of poles for the motor as 4 and the frequency of the motor as 1.5 Hertz. Okay, so let us calculate the speed of the motor using this equation, that is ns into 1 minus a slip. Okay, so we have to calculate the ns for the motor. Don't get confused with the ns of alternator. We need to calculate it. For that we need a supply frequency. Let us find using the value of ns for the alternator, which is 120f by number of poles of alternator. We will get frequency as 50 Hz here. And for the induction motor, we know the relationship between rotor frequency, supply frequency and the slip as Fr or F dash is equal to S into F. And here so we'll get the value of slip as 3% when we substitute Fr and F value. And now we can find the value of synchronous speed of the motor by using 120f by pm, that is number of poles of motor expression. Frequency is 50 Hz, so number of poles for the motor is 4, and we get 1500 rpm. So let us substitute ns and the value of s to find the value of speed. ns is 1500 rpm, s value is 3%, so take it as 0.03. We get the value of speed of the induction motor as 1455 rpm. Okay, another problem. What is slip speed? Slip and at what speed the rotor runs if the frequency of EMF in the stator of a 4-pole 3-phase induction motor is 50 Hz. In the rotor frequency is 1 Hz and the rotor frequency is 1.5 Hz. So we need to find the value of slip speed and the slip. Slip speed is ns minus n and the slip is s, which is ns minus n by ms. Okay, so note down the number of poles as 4, frequency is f, and frequency of the rotor is fr, which is 1.5 Hz, and we get the value of slip from these two frequencies. So slip is equal to fr by f, which is 1.5 by 50 Hz, and we get the value of slip as 3%. Now let us calculate the synchronous speed ns, which is 120f by p, and substituting value of f, number of poles as 4, and we get ns as 1500 rpm. Finally, the slip speed of the rotor, let us find out using the equation of n is equal to ns into 1 minus s, and we will get the respected values. Slip speed is ns minus n. So here it is 45 rpm. Thank you.